Math 113. This is our video for the last new material for the semester. We're going to talk about ratios and do some examples of them and a little bit of problem solving with it also. So a ratio is a way to compare two quantities. So we can say, that one quantity here is compared to some other quantity. So for example, you might see, if you're looking at colleges, you might see that the student to teacher ratio is 25 to 1. So that would mean there are 25 students for every one teacher. Or you might say that in a certain, in a recipe, the amount of flour to sugar is in a 3 to 2 ratio. So if there are 3 cups of flour, there are 2 cups of sugar. Sometimes we write it as a fraction. We also can write it with a colon like this. Today we're going to use the word 2, but they all mean the same thing. Okay. So there are a couple different ways we can think about ratios. So one definition we can have is for every A units of the first quantity, there are B units of the second quantity. And the order is important in a ratio. So if I say it's the student to teacher ratio, then if I say it's 25 to 1, the order is the order of the words. It's 25 students to 1 teacher. You can't switch, so they go together. The other way to think about ratios is saying if we divide the first quantity into A equal parts, the second quantity has B parts of the same size. Okay, so if we say the ratio is 3 to 2 for, let's say, women to men at a certain event, okay, then if we know that there are 30 women, if we divide this quantity by 3, then there are 3 equal parts of 10. Well, then that means this must be 2 equal parts of 10. They're broken up into the same size pieces. And we'll see that more in a little bit when we do some examples. Okay, so let's look at one example here, where let's say we're making a juice mix. So if you need to copy this down still, I would say just pause the video or rewind it, and you can have some more time to copy that down if you're not already done with it. So let's say we're making a mixture of juice and soda. We're making a punch, and we have red juice and we have lemon lime soda. Okay, and they're in a ratio of 3 to 5. Okay, so here's the red juice, and here's the lemon lime soda. So for every 3 cups of red juice, we're going to have 5 cups of lemon lime soda. Or it doesn't matter what the units are. We could say for every 3 drops of red juice I would put in 5 drops of lemon lime soda, right? It doesn't matter what the unit is. We're always going to have it in that ratio. Okay. So we have this table that we filled out during class. will make sense once I finish it here. Alright, so whatever our one part is, or our unit in a way, let's figure out what each of those parts would have. So let's see what we're saying here. So if one part of this is 5 cups, so our unit or our quantity is 5 cups. That's our one part. Well, we have 3 of those parts for red juice, and we have 5 of those parts for lemon lime soda. So if each of these is 5 cups, then altogether we have 15 cups of red juice, right? Each part is 5. We have 3 parts. That's 15. How about lemon lime soda? Think how much we have there. We have 25 cups. And all together, the whole punch is 8 parts, right? It's 3 parts red juice, 5 parts lemon lime soda. Together, mix them all up, we've now got 8 of whatever these parts are. 8 drops or 8 gallons or whatever it is. Well, here my part is 5 cups, so each of these is 5 cups. 5 times 8 is 40 cups. Another way to get this is just that it's these two added together. Okay, so what if now one part was 6 cups? So that's my unit, okay? So each of these is now 6 cups. Well, then the red juice, I'm going to have 18 cups. The lemon lime soda, each of these is 6. 6 times 5, I'm going to have 30 cups. So how much am I going to have all together? Well, if I have 18 cups of liquid and 30 cups of liquid, I'm going to have 48 cups of liquid. And another way to say that is each unit is 6 cups, and all together I have 8 of those. 6 times 8 is going to be 48 cups. Okay, so what if instead my one part is 3 liters? So let's say, picture this, right? You're making this punch for a big party or a big event. And so you want to make a whole bunch of it. So you have a pail that's 3 liters. So it doesn't even matter, even if you don't know how much the pail is, however much it is, if you take 3 of those of juice and 5 of those of lemon lime soda, you're going to get this mixture that you want to taste the way you want it to. So if my one part is 3 liters, I'd have 3 of those for for juice, that's 9 liters. I'd have 5 of those for soda, and I'd have 8 of those all together, which is 24 liters, which is also 9 plus 15. Okay, so again, it doesn't matter. I could just say, I have this water bottle, whatever this is, even if you have no idea how much it holds, 3 of these of juice, 5 of these of soda is going to be 8 of these. That's going to make the certain combination that we want. And then finally, the last example is, what if your one part, or your unit, is 1 gallon? Or sorry, a half gallon. Okay, well think about that now. I have half gallon, a half gallon, a half gallon. That's 3 halves, or 1.5 gallons. 5 parts, so again, think each of these is a half. Well, every 2 halves becomes 1 gallon, right? So now I have 2.5 gallons. And then to find the total, I could either add these and get 4 gallons, or if I have 8 halves, right, those 2 become 1, this with this becomes 1, so I have 4 altogether. Okay, so just showing you that no matter what size you make it, the ratio is the same. So let's say you are drinking something and you have lemonade and you have grape juice, and you decide to mix them. And you find the perfect mixture that tastes really good. If you have too much lemonade, it's too sour. If you have too much grape juice, maybe it's too sweet. You kind of have the exact right mixture. And then you're going to make that drink to serve at a party, you want to have that same mixture. So if you had half and half in a little glass, you want to have half and half in a big punch bowl. Or if you decided it was 3 to 5 was what worked best in the little glass, you want to have that same ratio even if it's a bigger portion. Okay? All right, so let's now say that we want to make some green paint. Okay, we're mixing paint to make green paint. And so we're going to mix blue and yellow paint. All right, so our blue to yellow paint is in the ratio of 2 to 3. So we want to make the same type of paint, the same shade. Okay, this is another example where obviously if you put more blue or more yellow, it's going to change the color. We want this exact shade. We're going to use 40 pails of blue paint. So what we can use as a tool for these, in which you will likely see when you're teaching, are strip diagrams. So we're saying, okay, blue to yellow, we're going to visually show that it's 2 to 3. And those parts are the same size, right? If I am mixing blue and yellow and I put in a cup of blue, another cup of blue, then I don't put in 3 drops of yellow. It's all the same size. So my yellow, even visually, we want to show that each of these parts is the same size. Okay, so part A says if I use 40 pails of blue paint, I want to know how many pails of yellow paint I will use. So this is going to that second definition or way to think about ratios, that if I'm splitting this into equal parts, 2 equal parts, then this is going to split into 3 parts that are that same size. So if I have 40 pails of blue, and I know I can split that into 2 parts, well, that means that each of these little blocks represents 20 pails. For every 2 groups of blue, I need 3 groups of yellow. So that's why I needed to know how much each group was. Each group is 20 pails. So each group of yellow is also 20 pails. And I'm going to use 60 pails of yellow. Okay, next one. What if, so I'm going to have the same ratio, blue to yellow, 2 to 3. This time now I know that I'm using 48 pails of yellow paint. Okay. I want to figure out how much blue. Well, since I know this ratio of 2 to 3, if I can figure out how much each of these parts is, then I know these parts have to be the same. Okay. So take a minute and figure out, if I have to take 48 and I can split it equally into 3 parts, how much will each of those parts be? So hopefully you're thinking about taking 48 and dividing by 3. If I do that, I get 16. So each of these little groups is going to be 16. In a ratio, if I'm splitting this quantity into this number of groups, I'm going to split the other quantity into that number of groups of the same size. So I'm going to have 32 pails of blue paint. Okay, I'm going to stop this video. I'm going to come right back. We're going to keep talking about this problem.